Hi students, good morning. I hope you are doing great. My name is Samuel Chukwu Emeka. In this video session, we shall discuss your Module 4 exam study guide. So as usual, you go to my website, Mathematics, Finite Math, Notes, Module 4 exam study guide. Please, before you view this video session, it is highly recommended that you have viewed the videos on a Module 3 homework study guide and Module 4 homework study guide. It is very important that you have done that because the Module 4 exam covers the contents from your Module 3 homework and your Module 4 homework. So these are the prerequisites. You need to view those, please. So because we have done, the questions we shall do in this Module 4 exam, we have done similar questions in a Module 4 homework. So because of that, we are going to use technology to solve our questions as applicable, because in the Module 4 homework, we did it both by formula or by hand and also by technology. In the Module 4 homework, we did by hand and we did by technology. So we spent much time there. Here we shall use mainly technology to answer our questions as applicable. Question 1, find the population mean or sample mean as indicated. So I have my StatCrunch open, so I'm just gonna put in the data right away. We did this by hand in our Module 3 homework study guide. So let's just go ahead and do it by technology. So I have 1, 9, 11, 12, 7. 1, 9, 11, 12, 7. So I will click on stats, summary stats, columns, variable 1. I click it, and then I just need mean, only mean, compute. So you see that the mean is 8. That's what we got here. Mean is 8. Question 2, find a standard deviation of sample standard deviation of those. So we are going to also use technology to do that, and this is what we are going to get. They said here round to 1 decimal place as needed. So we have discussed about this as needed before. When you have 1 decimal place as needed, that means if the answer turns out to be an integer, you leave it as integer. But if the answer turns out to have several places of decimal, then you need to round to 1 decimal place. So we can use here variable 2 to put in our numbers: 4, 45, 10, 51, 34, 22, 28, 32, 29, 30. Okay, you want to make sure you count it. This is 10 here. So you want to make sure you count it so you're not skipping any number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so start, and if you want to do this by hand, that's fine. Just, if you are doing it by hand, that is okay, but I will also recommend that you use technology as well to check whether what you did by hand was correct. Summary stats columns. Here we are looking at variable 2, and we just need the standard deviation. That is all we need. And we click compute. So we have this. So to 1 decimal place, this will be 14.2. That was what we got. Do you get it? Question 3. The data represents the monthly cell phone bill for a person's phone for 6 randomly selected months. Compute the mean, median, and mode phone bill. So I will go to my stat crunch. Let me use variable 3 this time. The data we have 35.28, 42.09, 39.45, 38.87, 43.39, and 49.26. It is the sample size is 6. We come here to verify 1, 2, 3, 4, 5, 6. So we need mean, median, and mode. So we go to stats, summary stats columns, and we only need variable 3. Okay, don't select 1 and 2. If you know you will make that mistake, then you just delete these. Okay, delete 1 and delete 2. Like delete the data entries in variable 1 and the data entries in variable 2. If you think it will confuse you, which variable do I select? Or another thing you can do is this. You could come here and you just put monthly cell phone bill. Monthly cell phone bill. See that? So to if you don't want to delete the data entries here. So stats, summary stats, columns, monthly cell phone bill. We need the mean, and we need median and mode. So you have to, it says here, select more than 1. If you look at this, select more than 1 with shift plus click or control plus click. So I have my hand on the control key. I selected 1, but I need to select median and mode. So I have to put my one finger on the control key, and then I look for median, I click it, and then I look for mode. I look for mode, and I click it, and I click compute. So that tells me monthly cell phone bill, $41.39. You make sure you put your your dollar sign, the unit. You make sure you put your unit. And the median is $40.77. And then there's no mode. Okay, no mode. Question 4. The following data represents the weights in grams of a simple random sample of a cookie. So you have these data entries. Determine the shape of the distribution of the cookies by drawing a frequency polygon and computing the mean and the median. Which measure of central tendency best describes the weight of the cookie? So we also use our stat crunch to draw our frequency polygon. Let me delete these results here. I'm gonna use variable 4 this time, and I'm gonna this is weights of a random sample of a cookie. So let me just call this weights. Okay, weights. So I now input my data. I have a 0.92, 0.89, 0.90, 0.92, 0.92, 0.87, 0.92, 0.86, 0.80, 0.89. So I have a 10, the sample size is 10. Let me verify that here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm gonna draw a frequency polygon. That is what I need to draw. So I go to graph. I go to because this is I go to graph because you have to select histogram this time. Okay, I go to graph, I select histogram, then I click weights. That is only what I need here, weights, and this is a frequency. Okay, not relative frequency but frequency. So you leave it like this and you click compute. So this is what I have here. This is what I have here. Okay, you see in this case, you see that the data, the frequencies are at the top of each bar, right? If you want to do that, you can do that. Let me show you. You go to graph, histogram, weights, and the value above bar, you check it, and then you click compute. So it tells you the value above bar. And you know, when you point at it, tells you the frequency and the weight. Okay, this means the weight is from 0.8 to 0.82. 0.82 is not included. You see, it is closed. It is a bracket for 0.8, and it is parenthesis for 0.82. So it tells you that 0.8 is included, but the other end value 0.82 is not included. Okay, so and then it says, what does it say again? The question, it says, you know, if you want to verify this, the frequencies, if you add it up, it will give you the sample size. 1 plus 2 is 3, 3 plus 2, 5, 5 plus 1, 6, 6 plus 4, 10. If you add up the frequencies of all the weights, it will give you the sample size of the data. Then they want us to calculate mean and median. So we go to stats, summary stats, columns. We get a weights. We get mean. You put down your hand on the control key because you are selecting more than one variable. I mean, more than one statistics. Okay, you select median and then you click compute. 0.889 and 0.895. See that? When you have this is skewed left. Okay, we talked about this in your Module 3 homework study guide. Skewed left, skewed right. This is skewed left, and when it's skewed left, the median is best describes the weight of the cookie. Question 5. 4 cars of the same model crashed at 5 miles per hour. The cost of repair for each of the 4 cars were, they gave you the cost of repair. Compute the range, sample variance, and sample standard deviation. So we use our, let us close these results. We use our stat crunch. Here we can name it cost of repair. Cost of repair. Or you can say repair costs, or you can say repair costs, or cost of repair, repair costs, anything you want, or cost of repair, cost of repair. If you notice, I put this in camel case letters. So we have a 415, 461, 400, and 220. So we need to find the range, sample variance, and sample standard deviation, and then we round to whatever they ask us to round to. So we go to start, summary stats, columns. In this case, I get cost of repair. So I get my range first. Let me look for my range. I put down my hand on the control key because I am selecting more than one statistics. Then I need to get variance, variance and standard deviation. So I have variance and then I have standard deviation. I want to get it this way, so that is why I clicked range first, because I want range to be on the result first. So whatever you want to be on the result first, you click it first, and then you click compute. So this is what we have here, and then you can round to the nearest round the variance to the nearest whole number. Okay, which is still a whole number anyway, and you round because it says as needed, so it's a whole number already. The sample standard deviation, round to the nearest hundredth. So this gives us 0.89. 6 is more than 5. You call it 1, add it to 0.89, it becomes 0.90. So your sample standard deviation would be $105.90. Question 6. To make a confetti, Fran and Stan bought 2 pounds of paper hats at $4.33 per pound, 3 pounds of sparkling stars at $4.41 per pound, and 3 pounds of Chinese coals at $2.59 per pound. Determine the cost per pound of the confetti. So you are already, it is good you put this in a table form, and you have your ingredients: paper hats, sparkling stars, and Chinese coals. These are the weights. When you ask to find cost per pound, this is like finding the total cost divided by the total weight. That's the formula right here. Yeah, it's kind of an average, it's also an average, but it's now cost per pound, total cost divided by the total weight. So this is the cost per pound. And you have for per pound means for 1 pound. For the paper hats, 1 pound costs 1 pound of paper hats costs $4.33. How many would 2 pounds cost? So you just multiply it by 2, and that gives you $8.66. Okay, it's just like saying that maybe one cheeseburger costs $5. How many would 2 cheeseburgers cost? How many will it cost? You just do 2 times 5, which is $10. So the same thing here. 1 pound of sparkling stars cost $4.41. So how many would 3 pounds cost? You multiply by 3. It gives you this. So verify these calculations to make sure that it is correct. After you get the total cost of each ingredient, then find the overall total cost. This is sigma. Sigma means the summation summation of all the total costs. Okay, sigma is a Greek alphabet. We mentioned it in Model 3 homework study guide. So when you do that, you now see that the cost per pound will be the summation of the total cost of all the ingredients divided by the total weights of the ingredients. And then you will get a $3.71. Question 7. After giving a finite mathematics exam, Professor C, Mr. C, Professor C, okay, Professor C determined the following 5-number summary for his class results. So I have a 5-number summary for these results. Of course, you know what the 5-number summary means. We did that in a Module 3 homework study guide. Okay. Minimum, lower quartile, middle quartile, upper quartile, maximum. So this is the 5-number summary. The question says draw a box plot of the exam scores. So I come to the start crunch. I delete this. Let me delete this result. Let me go ahead and in variable 6, let me put the 5-number summary. I have a 60, 68, 77, 89, 98. So this tells me that the lowest score was 60, the highest score was 98. Okay, this lowest is the minimum score, 60. This 98 is the maximum score. Then the lower quartile, Q1, or the first quartile, you can call it the first quartile or the lower quartile, that is 68. Then the middle quartile or the second quartile or the median is 77, and the upper quartile or third quartile is 89. So let's go and draw a box plot. You go to graph, you go to box plot, click on box plot, and we need variable 6. I can call this scores, you know. Why don't I call it scores? Always try to name your variables. So I call it scores, or you can say final exam scores, right? Okay, well, yeah, exam scores. You can just say exam scores. Exam scores. So I go to graph. I click on box plot, and I look for it here, exam scores. And I want to make sure you check this. Okay, make sure you check this. You want to use fences to identify outliers. In case if you have any outlier, you must not have an outlier, but in case if you do, you want to use the fences to determine them. And then you want to draw the boxes horizontally. You must have to check this. We want the box plots to be drawn horizontally. We don't want it. If you don't check this, then StatCrunch will draw it vertically. That is not what you want. You want it horizontally. And you just click compute. Okay. And here, if you look at this, if you just point your mouse at it, it tells you right away. Okay, lower limit 60, lower quartile 68, median 77, upper quartile 89, upper limit 98. Okay, so you now look and you select the correct option. Question 8. The data below represents the number of men's clothing in a random sample of a name brand and a store brand. A. Draw a side-by-side box plots for each brand of men's clothing. Label the box plots N for name brand and S for the store brand. So we're gonna do a side-by-side box plots, and this is how you do it. So I go to my start crunch. I will put N here for the name brand, and I will put S here for the store brand. Name brand, I have 30, 29, 28, 28, 26, 23, 22, 25, 32, 22, 24, 23, 35. Okay, it is 13 here, so let's make sure this is 1, 2, 3, 4, 5. 5 plus 8 is 13. All right, store brand should also be 13 as well. Let's put the data entries for store brand. 30, 20, 27, 29, 22, 22, 16, 17, 27, 33, 24, 26, and 23. Okay, so we got that. Okay, we want to draw a side-by-side box plots. That's what we want. So all you need to do, you go to graph, you go to box plot, you select this. Now you have to, because you are selecting more than one variable, you press your hand on the control key and click on this again, this. And you know, you want to check this, use fences to identify outliers, and draw boxes horizontally. Okay. Plot groups for each column. That is what we want. So you leave it right there, and you check these two boxes, and you just click compute. So this is the side-by-side box plus SN. Yeah, but now I think N S N. In this case, my N came before S. So you know you can do that, right? If you want to do that, just select, just click this first. If you want the N to come first and S later on, okay, that's S came first and then N here. So what you do is just go to graph, box plot, select S first and then N if you want it that way. You check these two boxes and compute. So you now have it this here, S first here and then N. Okay, and then you compare. And of course, if you point your mouse on each, it tells you the statistics for that variable, the 5-number summary for that variable, 5-number summary statistics for that variable. Okay, next question. Does there appear to be a difference in the number of men's clothing? Of course, yes. If you look at this, name brand has more clothing. The upper limit for name brand is what? 35. The upper limit, the maximum, you know, that's the maximum. The maximum for the store brand is 33. So The name brand appears to have more men's clothing, of course. And does one brand have a more consistent number of men's clothing? Yes. The name brand appears to have has a more consistent number of men's clothing. If you look at that, you check this, check the, if you check, this is the lower quartile, this is the median, and this is the upper quartile. If you look at this is kind of symmetrical for the name brand. Okay, it's kind of symmetrical, but for the store brand, you see that this area here is greater than this area here. Okay. Question 9, match the linear correlation coefficient to the scatter diagram. Here, there's something I want to show you here. These are all negative negative values of the correlation coefficients, but this does not show any, there's no straight line. The points are kind of scattered. So it shows a very weak negative linear relationship. Very weak. The points are kind of scattered. So that's why you have negative 0.038. Here the points are perfect, in a straight line, although this is a negative slope. So R is -1. Here the points are kind of scattered, but they are not. They are more towards, they tend towards a straight line better than here that the points are scattered. Okay, so this is a perfect negative correlation. This is a strong negative correlation, and this one is a weak, very weak negative correlation. Okay, so that's what I wanted you to notice here in these scatter diagrams. Question 10. A doctor in the Divine Mercy Family Medicine wanted to determine whether there was a relation between age and HDL. HDL means high density lipoprotein cholesterol. HDL cholesterol, and then LDL is the low density lipoprotein cholesterol. He randomly selected 5 patients and obtained the following data. So draw a scatter diagram treating age as the explanatory variable. So we draw a scatter diagram here. We go to our start crunch. We have age, and we have a HDL cholesterol. So let me expand this here. HDL cholesterol. Okay. So for my age, I put 49, 61, 38, 38, and 44. Okay, this is my explanatory variable, and that is my X. Then my HDL cholesterol is my response variable, which is my Y. This is 55, 42, 44, 57, and 28. So I go to start. I go to regression. I go to simple linear. And once I'm in simple linear, X variable is the age, and Y variable is the HDL cholesterol. Okay, you see that? And I just click compute. So we did this in a Module 4 homework study guide, This is the linear regression. Y is 53.872131 minus this x. So you want to put it in the form y equal to mx plus b. Yeah, I'm my ex-boyfriend. So it will be y equal to negative 0.1885249x. Negative 0.1885249x plus 53.872131. So, and the second one is your scatter diagram. This is your scatter diagram. We did this in Module 4 homework assignment, so you kind of know what I'm talking about. This is the linear regression equation, and this is the scatter diagram here. So if you want to compute the linear correlation coefficient, this is the correlation coefficient here, right here, what I just highlighted, negative 0.1548083. Okay, so, and here we did an example like this also in Module 4 assignment. I think here it says comment on the type of relation that it appears to exist. So comment on the type of relation. The linear correlation coefficient is what? Is 0. So it's close to 0. Negative 0.1548. So it's close to 0. So no linear relation exists between age and high HDL cholesterol. Now this is just based on the scatter diagram and the linear correlation coefficient. You can, this is the type of this relation they're asking for here is just based on the scatter diagram and the correlation coefficient. The next question, you have the this data x and y, and we just use the same method. Let me close this result. I can put x here, and here I put y. So for my x, I have 2.1, 3.8, 2.9, 4.8. Then for my y, I have 3.8, 1.4, 3.7, 4.8. So go to start, regression, simple linear, x, get your x, y, get your y, compute. So I want you to look at this. This is the scatter diagram here. And then we now have to put in the additional point. Additional point is 10.5 and 9.4. So if we put in here 10.5 and here 9.4, we go to start, we go to regression, simple linear, select your x, select your y, compute. So I want you to look at something in a moment. Let me get this here, and let me get this here. So do you see that when you have this additional point, it appeared to strengthen the relationship? See that? Because of this additional point that you put. Now this was the 4 points, only 4 points. 1, 2, 3, 4. If you look at it, you see how they are scattered. But now you put this outlier, these are outliers, and it appears to strengthen the relationship. So explain why correlations should always be reported with scatter diagrams. Of course, the scatter diagram is needed to see whether it is being affected by outliers, as you can see from here. Okay, because of these outliers, it appeared to strengthen the relationship. Question 12. See the data below. Determine the least squares regression line and then graph it on the scatter diagram. Yeah, this is similar to what we just did. We can do that. Yeah, let's just change this x and y here. We have 4, 5, 6, 7, 9. Then for the y, we have 6, 8, 8, 12, and 15. So start regression, simple linear. X, select x. Y, select y. Compute. And this is the least squares regression line right here. Now you have to round to whatever they say you should round to. Okay, whatever, I think 4 decimal places. So if you look at the way I did it, you will say you round to what they say you should round to. And then the next one becomes your scalar diagram right here. As you can see, you know, if you look at the correlation coefficient here, if you look at this, it has a high correlation, has a high positive based on the correlation coefficient 0.97 301847. Okay, any question? Hope you understand it. Question 13. The data shows the pulse rates beats per minute of 9 people in the city of Y, Arizona. You know, there's a city called Y. City of Y, Arizona. So treat the 9 people as a population. And you want to round to the nearest tenth as needed. So determine the population mean pulse. The same principle is what we do here. If we use start crunch. So let's call this, you know, we can say pulse rates. Pulse rates. Then we have 89, we have 66, we have 62, we have 64, 79, 77, 70, 85, 72. So we just want to determine the mean, the population mean. Population mean. Okay, so you just go to start, summary stats, columns, pulse rates, select only mean, and that is it here. That's the population mean here. They say you should treat them as population, so we do that. Okay. The next question is determine the sample pulse mean of these samples. So you have sample 1. Meanwhile, I love these names: Peter, Mary, Jude, Claire, Cynthia, James, Kieran, Timothy, Kizito. I use the name of Sense. You know, I love them. I love their names too. So sample 1, you James, Kizito, Timothy. So you have a 77, 72, and 85. So this sample is pretty much simple. You can just do, what you can do is this. You can, variable 8, you can just say sample 1. Okay. And the sample 1, you have 77, 72, 85. Right? And then let's look at sample 2 as well. Let's do sample 2 right away. Sample 2, here we have a Cynthia Kizito Claire, which is a 79, 72, 64. 79, 72, 64. Okay, let us get the sample mean of both of these samples. Start, summary starts, columns, sample 1, mean. Okay, this is the sample mean of the first sample. Then start, summary starts, columns, sample 2, mean. This is sample mean of the second column. Of the second sample. So you see that the mean of the first sample is greater than the population mean. You see that. But the mean of the second sample is less than the population mean. So because of that, we say that the first mean, this one is greater. We say it overestimates the population mean. And then for this, the sample mean of the second sample, we say it underestimates. If it is greater than, if this mean of the first sample is greater than that of the population mean, that means it overestimates it. And if the mean is less than the population mean, then that means it underestimates it. Okay? Overestimates and underestimates. Question 14. We have this data. Find the least squares regression line. That's the same thing we do. Let's delete these results. We're gonna use the data is what? Weight of cars and miles per gallon. So somebody wants to do a research to see whether there is a relationship between the weights of cars and their miles per gallon. So weight, we put a weight. We can put weight here. And then miles per gallon. So let's put in our data. For the weight, we have 2585, 3085, 3400, 3760, 4170. And then for the miles per gallon, let me extend this to be clear. This will be 26.8, 21.3, 22.7, 19.8, and 17.8. Okay. So I go to start, regression, simple linear. My X is the weight. My Y is the miles per gallon. Compute. So I got the least squares regression line. That is right here. That's right here. Okay. Then the next one. What does the slope indicate? So the slope indicates the average change in miles per gallon for an increase of 1 pound in weight. Find the y-intercept. Before we find the y-intercept, the y-intercept means to find the y-intercept, you set x to be 0 and solve for y. So let us see whether it is reasonable with this model to find the y-intercept. What is the lowest x that we have? The lowest weight. The lowest weight that we have is 2585. So 0 is less than that. 0 is outside the scope of the model. And because 0 is outside the scope of the model, it is not reasonable or it is inappropriate to use this model to find the y-intercept. Because we don't know how the behavior of the model outside the scope. The regression model, this regression equation, okay, which is the regression model, we can only use it for the explanatory variables within this scope, within this range, from 2585 to 4170. If it is less than 2585 or if it is more than 4170, we don't know the behavior of the regression model. So we don't know how it's gonna behave. So we cannot use this model for those weights below 2585 pounds or above 4170 pounds. Does that make sense? I think we explained this in a Module 4 homework assignment. Now predict the miles per gallon of B. So before we predict the miles of gallon of B, we want to see whether there is a relationship. The correlation coefficient is this, negative 0.93358,159. Now let us find let's find a critical value. Now this is a sample size of, and we did this in Module 5, Module 4 homework study guide. Now the sample size is 5. So let us find a critical value for a sample size of 5. That gives us 0.878. We now say, okay, the absolute value of this correlation coefficient, the absolute value will be 0.93358,159. So because the absolute value of this correlation coefficient is greater than the critical value for a sample size of 5, okay, and which is greater than 0.878. Therefore, there is a relationship, a positive linear relationship. Well, not positive, negative, I mean, because it's a negative because the sign here is negative. But there is a relationship because the absolute value of this is greater than the critical value for a sample size of 5. First, that is the first thing, that yes, there is a relationship. But what kind of relationship? It is a negative linear relationship because this has a negative sign. The correlation coefficient is negative. Okay, so once you have now established that there is a relationship, you can now use this regression model to predict the miles per gallon for car B. And for car B, what is the weight? The weight is 3085. So we have to use this equation. Wherever we see x, we put 3085. So multiply it by this slope and add it to this. Okay? And this is what you have. Approximately 23.32 miles per gallon to 2 decimal places. To compute the residual for car B, residual means observed y minus predicted y. So the observed y for car B, if you look at the table, for car B, the observed y is 21.3 miles per gallon. Okay, so what would be the predicted y? We just did it, 23.31599,839. And some of you might ask me, why did I use the original value? Well, I did that in Module 4 Homework Study Guide. You see why it is important to view the prerequisites. So if you're still solving, okay, you use the actual values. You only round your values as the final answer. But when you're still solving, when you're using it in intermediate calculations, it is better you use the actual values. So, but on the final answer, you can now round. You can now round your answer according to the number of decimal places that was specified in the question. So you will see that our residual is negative 2.02 miles per gallon, and that is to 2 decimal places. Is the value above or below average? Of course, when we say in the Module 4 Homework Study Guide, we talked about if the residual is positive, it is above average. If the residual is negative, it is below average. And if the residual is 0, then that means that the observed y is the predicted y. Please look at those, view the video and read the notes as well. Okay, it is important as you view the video that you also go through it with the notes so that it will make sense. Question 15, the last but not the least. The number of absences X and the final exam score Y of a sample of 5 students in Mr. C's calculus class is shown below. So we use the start crunch as usual. I'm just gonna put number of absences here. Let me extend this, and then this is the final exam score. Final exam score, and I'm going to make space here. So what we now have under the number of absences: 0, 1, 2, 3, 4, and then the final exam score, we have 88.4, 86.2, 82.1, 73.9, and then 70.8. Okay, so start regression, simple linear. My X is number of absences, my Y is final exam score. Compute. Okay, this is the least squares regression line, or the regression equation. And then what does the slope indicate? So please go through it. It is similar to what we just did. It is just similar to what we did in the previous question. Okay. And if you have any questions, please let me know. And watch out for other videos as well. Okay. Thank you so much for listening to this video presentation. And you have a great